please have your notes out.
What cable is it?
You are?
Okay, I'll vote for you. I think we should all vote for you.
Eric
from valedictorian.
Okay.
Tommy Day?
NA?
Yes.
I don't want to take your phone for the entire class.
Yes.
Eric? Eric? I don't want to take your computer for the entire class. Everybody else? I should move you all up.
I have a question.
Well, then I want you out with your notes out, ready to go before I confiscate Taylor's phone.
I don't remember which one it is.
Lies. Where's Sam? There it is.
Wait, what? No, because me. Let me know if you do.
Wait, which no package is S?
S. Same one we're always using. Okay. Whoa, White. Sorry, I thought I had it on the screen.
You've gone through so many.
You've had it since last day. It's the same one we've been using the whole time.
Where's the? Why are you thinking?
Because you're about to do something like a Kahoot.
I really don't just for. Is it gonna be one of those weird boring things?
What?
Like, can you scroll up so I can see what it is?
It's the same.
I don't have an app.
Yeah, no, I don't have that.
I don't have that.
We were working on it last day.
I wasn't here last day because I don't have it.
But Dylan was. And then we did oxidation, determination of oxidation numbers.
Unless it's in here.
Wait, no, I think I
You've done this. Like I swear.
Wait, this is where we were at.
Pardon?
I don't have
Sure.
This is where we were at.
Not right now. We're not.
Also-
I mean, like today.
Yeah,
I have like a couple extra.
I might have to have
Can I have one?
Well,
This is
Sweeney.
where we
it.
were
No,
at.
I didn't have this. I
Pardon?
didn't have this one.
Yeah.
I know, that's where we were at.
Did we finish the book?
No, we're not quite done the book.
No, I just have 4 copies of
But we should definitely have it. Well, you have it, right? No, it's not. Is that his?
I'm looking through my things.
Get out of there. Take your notes. Literally, there's a chance we get to the last thing we're gonna do today. I'd like to get- Excellent. See, Eshwan. Now I love Eshwan. Eshwan is now my favorite.
thank you.
Okay. Is this one fairly clear? Ahem.
Oh, I found it. Never mind.
Focus. Everybody looking this way? Everybody? Eric? If you have the table in front of you, and I said look up AU plus 3, I want to know, can it go oxidation, reduction, or both? Find it on the table. Tell me where it is. I'll give you an example that has that in a moment. This one will only do one. Can you find AU plus 3 on the table?
It's on top.
It's on top. Yeah, I picked an example. It's like right here. Where is it? Well, give me the number beside it.
1.5.
1.5. Right. So if you circle it here, if it is on this side, what is it doing?
Reduces.
It reduces. So that's undergoing a reduction. I'm going to put that down for a second, because that is distracting me. So this, we would say, can undergo reduction. What kind of agent is it?
Oxidized.
It's an oxidizing agent. Now, if I say, for example, cobalt solid, find that on the table. It's a metal, so it should be down low.
Negative.
Taylor, put it away in the
Negative
laptop.
0.28.
Pardon?
Negative
Negative 0.28. There it is. It is only on this side. You will not find it on the other side. So this is undergoing
This.
oxidation. Because if it's on this side, it can only go that way.
Yeah.
So it is losing electrons oxidation, and it's a reducing agent. Okay. What about copper plus 1?
They can do both.
We can do both. If we look here, we can find, there's copper solid, copper plus 2, so neither of those count. But there's a copper plus 1 here. Where's the other one?
That's down.
It's down. So copper plus 1 can do both. So this is both.
What
So-
do volts mean?
Means it can undergo a reduction.
No, like the numbers outside. What is volts?
What do they mean?
Yeah.
Volts.
Volts of what?
The volts
Of
that
the
energy.
voltage.
What voltage is created?
We're not physics. We don't explain voltage. We just accept it. Voltage is the.
Are we gonna do anything with them, or can I like forget?
Oh yeah, no, we can do something. Oh, from last day. Let's take a look. Actually, I'll let me do it after this, because I'll be able to show you how you can get the voltage of the lab you did last day from that voltage. Okay. So right now, I want you to just practice that. Go through these. Can these undergo oxidation, reduction, or both, or neither? And
How small?
you can use this so it's like a Kahoot. Huh? Ah.
Very
Where's the
smart.
hello smart
Kahoot
music?
from Wish.
Wait, how do you get it?
Oh.
Why don't you just do a good?
Because then I have to make it. I already had this made.
Kahoot's been around for a while. That's not a new problem.
Well, but this is right on here. I never forget it. Kahoot could disappear tomorrow.
I think this has
Kahoot will survive for 1,000 years.
It might. But you'd be surprised what I thought would last for 1,000 years and then turned out not to.
What did?
What?
Lotus 1, 2, 3.
What?
Exactly.
What is that?
Oh, it's the rival to Microsoft Excel. Somebody won.
Okay, but Microsoft Excel will last for 1,000 years. Unless the world.
Unless everybody goes to Google Docs. The only thing that saves Microsoft Excel is it literally can do anything you want. You can even program games in it if you really want to. I've been using Microsoft Excel for so long. I remember when it came with Flight Simulator.
Oh, that's what they made Flight Sim?
Oh, Microsoft had the Flight Simulator. They had an Easter egg in Excel. If you typed in the right things in the right cells, Flight Simulator was came. Flight Simulator was built into Microsoft Excel. A basic version of them, but a version that worked.
Does this still work?
I don't even know. The one Microsoft is not the scrappy little employees can get away with everything company it used to be.
How much coffee have you been drinking lately?
Well, I started this term at 2 shots a day.
Started.
Started, yeah.
We,
I am not yet at double digits.
Where
are you ever gonna like pull it back?
Oh yeah, usually in the summertime I slow down or stop. It's just, there's a lot to do between now and end of school.
Summertime you take like 2 weeks off so you can like.
Well, sometimes I just stop entirely, go cold turkey for 2 weeks.
What are you doing? What is your name?
And then I just take some Tylenol for the headaches, and then everybody tells me, I get kind of grumpy because everybody's telling me I'm grumpy when I know I'm not.
Are you grumpy right now?
No, because I have my coffee.
Oh, I see.
And I finally learned how to do a proper tie.
Yay.
I've been doing a half one for years.
That's it. That's pretty good, but mine's better.
Oh, what about mine?
I can tie it for you.
I've been doing the half one, and then I can now do the
Oh, the full one's so
Eldritch one.
Oh, that one's really
I
good.
like
You did a
that one.
really fancy one the other day.
Why
Yeah,
don't
that
you
was the
do-
Eldritch.
Why don't you
Yeah.
do that every day?
It takes me a little while, and I have
How
to.
long is a little?
When you're wearing a kilt, like when I normally wear a tie, it comes down to like here.
Uh-huh.
And so when you do that, when you're wearing a kilt, it looks dumb. So I have to get it hit, and I'm not used to wear it. So if I do the eldritch, I either end up with the ties like here or down there. And so it's the length that screws me up. Okay, we have nobody on. Oh, I haven't pressed start. I thought you were working this whole time.
Oh, I thought you were just waiting for us to get off.
Sorry. Go.
Eric, do our work for us.
I wasted so much time just getting coffee thinking that you were going.
How do we know whether it's oxidation?
Do not tell Eric to do your work
Can
for
you
you.
remind me how we know it's oxidation? If it goes this way,
Reduction, because it's a reduction table. And if it goes reverse, the other way, it's an oxidation.
ooh,
Click on button.
And they.
It's these ones.
That's an 4 plus.
Over here.
If it's
I don't have this.
Oh dear.
oxidation state,
That's why I was like,
It's a reduction.
it's like, yeah, it says it here.
Now we need to find the Hg, but in liquid form. So here. So it's gonna do the opposite. That's the opposite. Cu plus we already did that.
Like a lot. No, not like on the
I doubt that's even.
front of this one.
Like your little one. Like
Yeah.
Probably. Yeah, that's
when would it be neither?
When would it be neither?
That's the
When it doesn't exist on the table?
So doesn't exist on the table as one?
I thought we're checking what type of agent it is.
That's a good question. Number two
because it just says oxidation.
is what kind of things exist in a water solution?
Oh, can it undergo oxidation?
What kind of ion?
So if it undergoes, if
There's
it's
like-
oxidizing, it undergoes.
I don't know.
Well, in pure water, there's only two ions.
H plus.
H plus, no H minus. Now, is there H2O?
So can you check this out? Check this out.
Is that a given or we don't know?
No, you know. Is there water in water?
Yes.
Yeah. So if you're looking for what, will not go, if you're, let's pick one. I should probably read the top.
Might just be.
What does that say?
That says AU 3 plus.
No, or reduction.
In water. 1 molar.
1 molar. So if one of those compounds I asked you to find was say ClO4 minus, and it just says ClO4 minus, does it have 1 molar H plus in there?
I mean, it's a stronger oxidation.
Notice in my example, I've told you this is all that's there, but this one I said acidic. So now you know there's H plus there as well. But the one you don't have to worry about is if like there's something there that goes plus H2O, well, it's water. Obviously, there's water there. You don't have to worry about that one. But if this reaction, say, required another ion or something like in the equation, then it wouldn't go unless you had it. Hold it. Who asked that question? What is neither?
Me.
If there's something else you need and it's not there, it won't go. So for example, like sulfate
Yeah.
requires an acid solution. So if I gave you sulfate, but it's not an acid, it's not going to go.
Oh.
Right? Now, that being said, Taylor, can you put your phone away?
I'm done. I finished the.
Yeah, but I'm trying to talk to you and teach you the thing. MnO4 minus,
Yeah.
but it says H2O. Do you have H2O?
Well, like, could you, or like, just is it where you
Because all of these are in
water?
water.
So you would.
So you always have H2O. So that you don't have to worry about. You just have to worry if it says H plus.
What if it says in an acidic solution?
Then you know it's there.
Okay.
Okay?
Are we gonna get our test back today?
Be quiet. So many people haven't written it yet, and I realized if I release the results, it also releases the answers. Okay, who are we waiting for? Vinkel.
Yeah, it's cool.
Who's Vinkel?
What?
Okay. Oh, of course.
You're question 9.
My bad. Before you're getting your nails done with pride again.
I don't know. Every time I do, it really wrecks my nails.
Yeah, how are you taking them off?
Oh, I wear them off. No, until they fall off because I use
Yeah,
them.
so you're ripping them off.
Yeah, pretty much.
So you need to soak them.
Or sometimes I get like a floss and I put floss underneath it and go like that
You're
really
ripping
hard.
off- so what you're doing is you're ripping off a layer of your nail.
Yeah, I really hate that.
Yeah,
You
so
can go
that's,
back into the place and get them.
they'll take them off for you.
But then I have chemicals.
Okay, so take them off yourself. With
Yeah,
the
I
chemicals.
do. I rip them off.
No, you are taking, you're complaining. You're actually taking off a layer
Are we
of your
good?
nail.
Okay,
You can also open it.
I want to see if we're consistent. So one person
Holy correct.
might have it backwards,
Oh, we got it backwards. Yeah.
and if you have it backwards, then this will. Yeah, now the one. So one person said both. SN plus 4 is not on both sides. The person who said both, did you find it on both sides? Does the person who said both want to admit who they are so I can find out? No?
Well, I
It
put
was
the same
beyond
answers
answers
as pretty much all of mine wrong.
That happened to someone in the other class. I have no idea why.
Oh, yeah, I should be
L.
And
It's like, just hates you.
What?
mostly good.
Mr. Neufeld,
Mr.
why does
Neufeld,
mine
this
say
quiz is
wrong?
cool.
It's the same answer.
Yeah, I'm the same as you.
For some reason, for some people, it just decides you're wrong at the beginning, and it just marks all of your wrong. Happened to Theo in the other class, and we decided it was because he was German. And this class way, this has not had the same. So I don't know. Just compared to someone else, you can see if it's right. It looks like a couple of you had it backwards.
Yeah, that's a good trade-off.
This one you can find. That's the example I used. It is on both sides.
Oh, good trade-off.
Wait.
Fe plus 2 is on both sides.
It is.
It is.
I'm gonna go walk. I'm gonna go second.
Can you find it in both sides?
Oh, I was doing oxidizing at
There you go.
instead of
Where?
oxidation.
5.
Reduction, mostly good. A few people are. It's like someone joined the people who were confused. Cobalt plus 2 is not on both sides. You might have misread a copper. Copper plus 2. I'm not sure.
No.
This is.
It's.
Show me if you think it's on both.
No, it
So I
reduces
don't think
if
it was
it
a
goes right.
challenge.
Did you think it was on both sides?
We confused
No,
ourselves
we
even though we had it
we
right
got
at the
confused in
beginning.
the left and right.
Okay. Selenium is on one side for the one person who said it was neither, and two people, Eshwan and Taylor, are doing it the wrong way around. They're consistent here and also thinking
Wait,
this
can
is
you go
neither.
back?
CR207,
Was that one reduction, the last one? Oh yeah.
Yeah.
Wait,
Yeah.
we got that one right.
Okay.
Cobalt is.
Well, two other people didn't.
Cobalt, we just like.
And then CR207,
Oh.
Eshwan?
Yeah.
And then, the reason it has to say acidic for it to be true is because it has plus 14H plus.
It needs acidity.
It needs acidity to work. The 14 doesn't matter, that's just for balancing
Just
purposes,
H plus.
but it needs the acidity.
Yeah.
Review.
And, oops, I need to get back the pointer so I'm not in the way. Acidic we just did. And which is a stronger oxidizing agent? Everybody got that right. I'm not even going to go over that. Well done. And MNPB. Almost half of you got that wrong, so I will go over that one. So stronger reducing agent, MN or PB. MN. I don't know how you can get the other one perfect and this one wrong, but
Because there were multiple MNs, but the other ones on the top had charges.
where's P? There it is. Now,
What do you mean there's multiple MNs?
But they had charges, so people.
oh yeah,
Yeah,
MN
you're
solid.
looking- MN
So
solid.
if it has a charge, it's a completely different species in terms of oxidation or reduction. The strength you can read right off the side, so it's strong. And the stronger one then would clearly be MN. Anything, like there's lots of things on this side that have MN in it, but it's not NA? But it's not that species. You have to look for that exact species. For the 4 who got that incorrect, does that make sense? Anybody disagree? Want me to re-explain or go over another one?
I just misread the strong.
That would definitely make a difference. Okay. Looking at so this is looking at the table. What is written on the right? Oxidizing agents or reducing agents? Oxidizing agents. And
S?
pardon?
Is this like in the S?
Yep. Next page. Keep going.
Yeah, I'm gonna need my thing back. No, I don't have it. I swear. I swear. Isn't that right? I swear. No, where is mine? I don't have
So oxidizing agents.
Someone look at it. Who is that someone?
I'm going to start gathering this. Pause. Let's put them here.
Come on, Nick.
Oxidizing agent plus electrons.
Do you sell anything?
Eshwan. Don't disrupt my class by making fun of people.
Why would I steal those?
Oxidizing agents, when they react with an electron, become a reducing agent. So your table is set up like this. I am going to make things faster, group this. Infinite corner. So you have tables that look like this. Boom, boom, boom. If you have an oxidizing agent on your table as a reactant, so there's one reactant, and your other reactant is down below and to the right, then this is what I call a downhill reaction. It goes from here to here. It is spontaneous.
So those are the same chemicals?
So this is a reactant,
Yeah.
and that is the reactant. And this half reaction will go this way,
Oh.
and this half reaction will go that way.
So is the reactant below going to be the same as the reactant above?
No, they're different.
Oh.
Okay, I'm going to explain it with the one you did in the lab in just a second.
Okay.
So this is a spontaneous reaction. This is an electrochemical cell.
The other reducing agent?
Because it's like a battery, okay? And hold it. I'm getting way too distracted by the music. But then the music doesn't help.
It was so good.
What does that say? Reactant?
Reactant,
Sorry, I didn't mean to yell.
okay? Reactant. Here's our product, and here's our other product, okay? So to illustrate that, let's go clear the ink from the page. Your 2-beaker cell that you made that generated electricity. What were the solid electrodes made out of?
Was it like
Lead.
lead?
Lead, PB, yep,
And zinc.
and zinc. So we had zinc and we had PB. What solutions were there? So what was the solutions with the lead electrode?
It had.
Copper?
Nope. Copper was the second
It
one.
was like.
Lead nitrate.
Lead nitrate. It was actually, it was lead plus 2 nitrate. So it was lead plus 2. And the zinc side had zinc plus 2. It was zinc nitrate. Was it zinc nitrate or zinc sulfate?
Might have been zinc sulfate.
Okay, one of the two. Sulfate and nitrate are both spectators in this case. So this is how we can predict. This was a spontaneous reaction. You got electricity out of it. So this reacted with that. This reaction went that way, and this reaction went that way. So in your electrochemical cell, what you had was Pb plus 2.
How do we know which way it's going?
If you have those species, this is the only one that goes downhill. You go from left to right,
Oh, okay.
downhill.
So
So
whatever one's
it
above
would
on
be
this
Pb
table-
plus 2 plus zinc.
So whatever one's above on the table, you go from the left
Yeah,
to the right.
yeah, and you make a little, and I like that because spontaneous is like a ball rolling downhill that'll
Yeah.
happen spontaneously, goes to Pb plus zinc plus 2. And then, because you have all those possibilities, the only possibility that's going to be spontaneous is the downhill reaction.
Okay.
So if you're given a bunch of things, you just circle everything on the table, and the ones that go from left to right downhill, that's a spontaneous reaction.
And those are the reactants, and then the other two.
And the other two are the products.
Awesome.
If you want to know the voltage of the cell, voltage is given as E naught, I think, on this. You could also use V if that's more confusing, but let's see what it's taught. Yeah, E naught is volts. So E naught of the cell is equal to the E naught of the reduction,
Should we write this down?
yep, minus E naught of the oxidation. So you got a voltage, you were usually around 0.4, I noticed. If we want to know the voltage of the cell, what is the voltage of our reduction?
What is this? E naught of the oxidation.
Pardon?
It says
Minus E naught of the oxidation.
Oh, oxidation.
Yeah. Which one of these is the reduction?
What's E naught of the oxidation?
Yeah, the PB one, because it's going forward and these are all reductions. So this is negative 0.13 volts minus,
Wait, just a minute.
Yep.
On the one with the 0 at the bottom, is there a at the top?
that means oxidation.
Okay. But
Ox.
is there E naught of oxidation?
Oh yeah, you could do that. If
So
you,
0.13 volts, you said?
so our reduction was negative 0.13 volts. And then we minus the oxidation, which is
What, 7.6 is that?
negative 0.76. If you minus a negative number, you're actually adding. And so our final voltage of the cell that we should have got was 0.63. 63 volts. Did anybody get above 0.5 volts? No. Why didn't we get 0.63 volts?
Because of the tubing of travel?
No, it's fine.
Oh.
It's way stupider
It
than that.
wasn't pure?
May not have been, but actually they probably are, because zinc and lead are fairly easy to purify. At least nowadays.
Just didn't feel like it? I don't know.
Kind of. If you were doing a physics problem in the lab and someone said, why didn't you get the maximum force or velocity you should have through your calculations? What's to blame?
Air resistance?
Air resistance, friction. You have wires, they have resistance. You have little alligator clips that don't stick on very good. And you're using, so the whole thing is real life. And so that's the maximum you could get. You got somewhere underneath that. If you did the lab if you got 0.7, now you've made some fundamental error somewhere. You've done the lab wrong. It's impossible to get 0.7.
Wait.
But if you got 0.4, that's fairly reasonable.
Has anyone gotten has anyone achieved that level of perfection? Or could you?
Oh, 0.63? If you had a good you were making a battery, so you made, one of my work terms, as a chemist, I've made batteries before. So what I would do for the electrode is I'd take a flexible, thin layer of lead, so the metal, lay it flat, put a paste in between, it could be cloth or something, and then I'd have it the metal would stick out a little beyond that. And then I would lay out a flexible sheet of zinc metal on top of it, and the metal would stick out on this side, and then put a layering of cloth or paste on it, and the paste would have the ions, the zinc plus 2 and the lead plus 2, and then I would just roll it like a cinnamon bun. That's how you get an actual cell. When you roll it, now you have all of that contact. You don't have a tiny wire moving things. You actually have a battery. You have a positive and negative ends, and all that chemistry is packed in there, and there's very little room for it to move around and do something wrong. So yeah, they can get 0.6 volts. And if you mess around with the concentration, you can now adjust the voltage to whatever you would like it to be. There and there.
So that's 0.63 volts then?
Yep, I think
How
so.
do we know like which one is the reduced? Wait, it's like 0.13.
Which one's undergoing reduction?
Wait. The lead, I think.
The PV. The
My brain
forward,
is undergoing reduction. Though.
forward is reduction,
Forward. Okay, yeah.
It's going to the
and
right.
reverse is
Right.
oxidation.
Right is reduction, R.
So it's reduction minus. The reason the minus sign is there is because this is going backwards, so the sign just flips. And by putting in the formula, we just make it easy. Yes.
Would the lead be the anode and the zinc be the cathode?
Oh, nice. Yes. So in here, this is the reduction. So that's the GER. So what did you say that would be?
The anode?
That would be the cathode.
Or the,
And the reason and the mnemonic for that, but thank you for thinking of that. This is oxidation, so that's Leo. And my mnemonic for that is that it's GERK, because this is all like consonants, and so you have a consonant with consonants. And Leoa sounds like vowels, and so you have a vowel with the vowels. So this is the anode,
Anode is negative, right?
and that is the cathode. Oh, don't do that.
Is there starting to be a strike?
Oh, wait.
Electrolytic and electrochemical cells will flip the charges. The anode and the cathode are set by what reaction happened.
They're not
So the
positive.
cathode is always the reduction,
Okay.
and the anode is always the oxidation. If you have an electrochemical cell, then you'll have a certain negative and positive. If you have an electrolytic cell, you're actually pumping electrons in, so you hook them up opposite. So you have different positives and
So
negatives,
what's
right?
it for electrolytic?
Pardon?
What's the positive and negative for electrolytic?
So electrochemical, your sheet actually labels it. So if you have a, the one with the light bulb is the one that you're generating. So electrochemical cell, people have memorized anode is negative because you're used to batteries and cells.
Yeah.
But an electrolytic cell, you are sucking electrons out of the anode. So it's not negative, that's where you connect the positive terminal
Oh,
to.
so
So it takes it out.
So that, or for that one, anode is positive.
Yeah, so anode is positive.
And
Because
that's
it's
for
sucking the
electrolytic.
electrons out. Yeah,
That's for electrolytic.
yeah. Because you're forcing it to happen. That's for electrolytic. Okay, spontaneous reaction, calculating the voltage. Spontaneous is downhill. And for sake of pedanticness, here's the non-spontaneous reactions. And I'm going to make them up. So if you have this, and these are your reactants. This is going uphill. So this is
Spontaneous.
non-spontaneous. This particular one requires energy. Or I'm going to just put needs because I can't spell today. So if you pumped electricity into this, you could get it to go. Because you do have a reduction and you do have an oxidation, but it's not going to spontaneously go on. No, it's non-spontaneous. And then you have the other examples that I call the stupid examples.
So
But they're-
basically, like if it goes down, that's like
Electrochemical,
It's always going to be spontaneous if it
Yeah.
goes down because it's like
it
water.
positive voltage.
down.
Yeah,
Okay,
yeah.
I get that.
Water flows downhill. This one's uphill. You have to put that voltage into it in order to figure out what to do. And this is the electrolytic cell.
Yeah.
Yeah. Yeah.
What did you write at the bottom?
Needs energy. There we go. Electrolytic needs energy. Oh. Electrolytic. And for pedantic purposes, if I have two oxidizing agent, will this reaction happen?
Needs
No.
energy.
Oh.
So this just won't react, cannot react. cannot reaction. There's no uphill, there's no downhill. Sometimes students do that and they go, oh look, it's downhill. I'm like, what do you, they're on the wrong side. That's like putting an acid with an acid. And to be pedantic, I do the same for the other side. Oh, hold it, did it not? Oh, it's up above. Bring it down.
Carrot reaction? No,
The carrot reaction?
Have on.
I think.
The carrot.
It does kind of look like.
Wait, what does that red thing
Yes,
say?
actually.
Yeah, don't,
Cannot-
it's a
cannot
carrot
react.
reaction.
Carrot.
No, no,
This is carrot.
No.
Nice guys who were very insane.
So if you have two on the other side, we have another carrot reaction.
We're just omitting.
I'm just going to commit to it.
Carrot.
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 Yeah. Because I don't like carrots.
What is that?
They're a
not
disgusting
everything?
vegetable.
Is it saying use
Okay,
everything?
that does look like carrot, I'm not gonna lie.
You brought carrot that
Oh,
time.
use everything.
You did right.
Oh, he actually wrote it.
Carrots are almost as bad as broccoli, which is almost as bad as cauliflower,
What do you think of steamed
which
broccoli?
is all, oh god, it's so disgusting.
What about the
Steamed
spinach?
broccoli with some like with
So
some butter?
gross.
Oh
What about
my
some soy
days.
sauce with some
I,
No,
I
that's weird.
strongly
That's
dislike
okay.
spinach.
Butter?
Asparagus.
No,
Avocado.
no,
What vegetable? Sorry, what vegetable do you like?
corn.
No.
Anything else?
Yeah, that's good, that's
But
good.
putting soy sauce is
Nope.
You do soy sauce
Oh,
and
no.
barbecue, that's-
Iceberg lettuce can be okay.
Hey, Eric, make it a dish.
I've made cauliflower rice,
My mom will put,
and
like,
if you do it right,
straight up.
but if you make it right, it just tastes like whatever you made it with.
Okay, what about like a broccoli
It's
cheese
just a weird
soup?
If there's enough cheese, so you don't taste the broccoli.
Okay. How would you use like soup vegetable? Like vegetable where you
Okay.
peppers. Peppers.
Take these pears. Tell me if they will be spontaneous or not
On the app.
On the app.
on the app.
Okay.
Go, go, go. Go, go, gadget machine.
They're gonna get screwed.
Mr. Newcomb, can I get my phone back for activity, please?
Yes, okay. Oh, you want me? I'll bring it to
What's it?
you. Please do the activity.
Hello, smart.
It just reloaded the old one. How do I?
Oh, I have to press start.
No, we have to leave.
No, 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 stop.
Wait,
stop,
no,
stop.
Ryan, bruh. It says 3 connected students.
Oh. I'm in the old one.
There, it's running now. It should have shut the old one down.
I'm not even
Oh,
in.
yeah, yeah, I got it.
Oh, yeah, 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 yeah.
Mr. Neufeld, I hope you do well. As I hope Neuf does, and Mr. Neufeld with a lowercase. And the other, there's two Mr. Neufelds.
Here, see you people.
What does as? Oh, spontaneous.
Spontaneous or non-spontaneous?
One more. Yeah, so there's only one.
Is there only one plus two for
It goes
copper?
from O to R.
Yeah,
Okay.
I think so.
So
I may be wrong.
would it then be?
When it goes downhill, it's good. It goes
Wait, Mr.
uphill.
Neufeld, why would it go from left to like
Oh,
Wait, so
backwards?
Oh,
can
wait,
it
so-
can it
so
even
that-
be
so
spontaneous?
If you force,
Oh, and
you remember the second part of the lab where you had a thing of, that didn't work until you added electricity, right? So that would be an uphill reaction.
How do you like? How are you able to tell?
Offer exists.
You have one on one side, and the one on the other side is higher up. And that's the only possibility. So until you add electricity, it just won't go. No, non-spontaneous.
Because first we have copper higher up than zinc.
So
Copper would slide down to zinc.
if you have something up here,
Yeah.
and like it goes like this and blah blah blah, and you have something here,
Yeah.
as long as they go downhill, it's spontaneous.
What if there's two solids of copper?
Which one do we
Both
use?
could react.
Okay.
Now, if it's Taylor,
Yeah.
if it's a spontaneous reaction, they will pick the ones that are farthest apart because the steeper the hill, the faster you go.
Zinc 2 plus gives.
The old
Farthest apart is this one.
Okay.
So it's spontaneous. What? How is it not spontaneous?
And I 2 plus. Like,
This is so confusing.
No, no, it's not. It's not that.
Wait, zinc 2 plus.
That's not spontaneous. Oh, yeah.
If you're minus
So if it's uphill, it's not spontaneous, right?
Right. Uphill is non-spontaneous.
And then what does that
Both on the same side is non-spontaneous.
non-spontaneous? And I already had already, didn't we?
Ah. Well, if you get them all wrong, though, then that means you have it completely backwards, which is actually 95% of the way there.
Oh. This would be better.
I once gave a true-false a true-false test to like a group of grade
What?
9s.
Yeah.
It was like 25 questions long. One child got 0%,
Oh.
which is like, that's actually pretty good.
So I'm not.
It means you know it exactly, you just have to reverse it.
Okay. What the heck? BR minus. Oh wait. BR minus would be 2 BR minus. Because that's only
What if they're
minus.
both in
Just remember, there's a flaw in
Give this and then.
Why is there a flaw?
nickel
What for SM?
plus 2 and
Yes.
CO plus 2 are on the
There's SM
all on
too.
the left side.
Right, so are they spontaneous?
No, but
There you go.
neither is non-spontaneous.
Yeah,
They are non-spontaneous.
If it
They
doesn't,
never happen.
if it doesn't go, then it's not spontaneous.
It's
That's just really bad wording.
This should be a fail.
okay.
It should just
There's
there
another
should be a
problem.
option for no reaction.
I will take that under advisement, perhaps change it for next year. I will call
Next
it
year.
Eric's rule.
Eric's rule.
Yeah.
What the heck? Wait, I don't get this. It's like BR minus, but there's only a 2 BR minus. Is that?
Oh, no, the number doesn't matter, that's just for balancing. Yeah.
What's your favorite meal that has a vegetable that's not corn? What other vegetables do we eat?
Corn on the cob.
I thought it's not corn.
Well, I do roast broccoli,
Okay. What
and
about broccoli?
I dislike it less when I do that.
Okay, you should air fryer it with parmesan.
Peas are like
I hate
only minorly disliked. Like I regularly have peas because I just, like, they're there.
What if you, like, you should air fry broccoli with parmesan. That's,
I've done that. Everybody loved it. And they were, less bad. Like ketchup's great. Like a tomato? No, that's disgusting.
cucumber?
Mostly water and disgusting.
Cucumbers are pretty non-confrontational vegetables.
Are you a fruit or a vegetable?
Okay, zucchini.
Zucchini isn't really a food. It's more like a structural thing.
What?
Like you see them and they're just like, they're like the parts of the pumpkin that nobody eats that you peel out, but they made a whole vegetable out of it.
Oh, that's valid.
Pardon?
Zucchini is
What
I just,
besides
okay,
all
like,
seeds
how
is
do you
vegetable?
consume vegetables?
Reluctantly.
But
Like a chore. Like I have to do it. And avoid it at every opportunity.
Mystery
Okay.
code.
Go on and say
If
it
we
out loud.
finish this early, would you be able to leave early?
Yesterday, but I actually could go before 1.
We have one more thing to do. Technically, we could, if we finish it today, we're done the course.
Wait, we don't have to do W or like.
Technically, we've done it with our little lab and the handout. We've done all the other ones. There's just one more thing balancing.
So we just
Wait, like balancing the reactions, just like
Yeah.
We still need the K back
we
though.
did that in grade
we
11.
couldn't we just finish that on Saturday?
Yeah, it'll be fast.
How fast is it?
Okay,
Nah, what are we gonna do?
I'm gonna say end because this doesn't seem to be progressing anymore.
Saturday and Monday. How do you know?
Okay, let's check.
Why?
2 people.
Did it decide I was wrong again? Oh, it decided I was right.
100%.
Good?
Correct.
Yeah.
Correct.
Okay. Good.
Hey, I got it correct.
Congratulations to those who got
We
100%.
got 100.
How
But-
is there a question mark?
Eshwan? You're just loud. I just want the people who didn't get it right to be able to focus.
Question mark is
So, is there anybody who wants to ask? Because if you're finding it on the table, you should be connecting something on the far left, and and something on the far right. You should be able to go like that. Question marks are people who didn't answer, so somebody who disconnected or something like that could be one of those. Any questions on it though? Because I don't know. I have no way of telling who got it wrong.
No.
Okay. Same. So somebody has it exactly reversed, is what that tells me, because they're exactly reversing it. They got back on board for this one. These are non-spontaneous. This one, ooh. Chlorine 2 and bromine. Why did so many people not get this one? So chlorine 2 is here. And bromine minus is there. That's spontaneous. Were you confused by the 2? Is my only question. If there is a number in front of it, it does. That's just for balancing purpose. That doesn't change what it is. So if you're looking for bromine minus, that's still bromine minus. Check mark. That's it. Any other interpretations of that that I could address? Because that's usually the most common mistake. Raise. Go away. Okay. Everybody got that one right. Well done. And 3 on that one, non-spontaneous. Just by looking at those are both on the same side. Why would you? If you got confused by the manganese who have a charge, maybe because there's a lot of those. Any of the 3? Want to guess or let me know? See me if you continue to be confused about that. And you can always try those again as well. Okay, that's just more of the same. So we're going to stop there and pull out the notes I'm about to give you.
Well, do we just
Can I
give
have
like a
another
bunch?
one of these packages because mine is 3 pieces.
That is true.
Thanks.
Mr. Nuka, is it a good idea to have a lab tech that stores aqueous iron 3 chloride in a nickel container?
Yes, you can now answer that.
How do we know?
Another one.
How do we know? If it's a good idea?
Not that thing. It is like one example per page. Why are you saying yelling names?
All time.
His?
I don't know.
I think
Is this yours?
Really?
yeah, but not doesn't have enough idiot.
Yeah, I
Or
told
they like
them.
have an actual capsule
yeah, you
on
did.
a website.
Mr. Newfeld, I don't understand what this question is asking when it says, is this a good idea?
Is it a good idea?
I said gonna, so I didn't know. As I
If-
didn't follow them.
With the knowledge that we just did spontaneous and non-spontaneous.
If it's non-spontaneous, it's a good idea, right? Because nothing's gonna happen. That's what I'm thinking.
Yeah. But I'm not doing that right now. You can answer that for homework. Ask me next day. View, zoom, page width, and okay. Where did my pen go? I'll use me. There it is. Okay. This section is how to balance redox equations. Redox equations are a little bit more difficult to balance because they include the charge. So up until now, the only thing you've ever balanced is the species. You just looked at the atoms and balanced them. And we've never given you a problem where that would fail. That can fail all the time. Because if you balance the species, but there's too much charge on one side's more positive than the other, it's still not balanced because you haven't accounted for the electrons. So, we use a mnemonic to remember in what order to do it, and the mnemonic is major hydroxide. First, you balance the major atoms, and that's everything that's not oxygen or hydrogen. Hydroxide is OH minus. So you then balance the oxygen, you then balance the hydrogen, and then you balance the charge with Dylan, focus? And then you balance the charge with electrons. Rather than going through the rules, I'm just going to do the first one. You don't have to do it step by step like I'm going to. If you'd like to, because then you'll have the full explanation, you can. But when I ask you to do it on the board or whatever, you just do it as one line. I'm going to do it step by step so you can see every single step, and then we can go back if you're confused. So for that purpose, Dylan,
Yeah.
I'm going to start off with here. So here's the main equation. We balance the Echelon. Focus. I'm going to ask Echelon, are the major atoms balanced? Yes. There's
Yeah.
one ruthenium and one ruthenium. So
You skip a lot.
good. Take it down. We're going to balance the oxygen. Na, are the oxygen atoms balanced?
No.
No. Here's how you balance oxygen. As you walk out, watch this. You balance oxygen by adding 2 waters.
Oh my god.
Isn't that amazing?
That's insane.
I thought that was pretty good. There is always water in solution. So these balancing assume that there's water there and that will always react because it can.
Then you would add hydrogen.
So, yes, so oxygen we balance with H2O. Hydrogen we balance with H+. So now I've got to carry my water down because I'm doing it step by step. You don't have to, you can just have it on one line above, but I put it there in case you want to copy it down. So, where would I put the hydrogen?
Next to
left
On the left side, how many?
4.
4. Yeah. So the balancing, this isn't very difficult balancing. But now we have to do the charge. So 4H plus this plus 2H2O. So for this side, what is the total charge on the left? And what is the total charge on the right?
That's one.
What's this one?
That's one.
Not 1,
Is that 4?
4.
4.
Because there's 4 up, so you take it. So this one is neutral, and this is +4. We can only add electrons. So, what charge are electrons? Negative. To make both sides the same, how many electrons would we add into which side?
4 to the left. 4 to
To
the
the
left.
left, yeah, 4 electrons. And then I will take these out because these are, you wouldn't want them in your final equation. Now, let's say that this side was +2 and this side was +4. Then you just add 2 electrons. It would be +2 and +2. They don't have to be neutral. It's not like you have to make them both the same charge. You just make them the same. It doesn't matter what the charge is. Yes?
Looking at the double arrow, does that mean the same thing as equilibrium?
Yeah, it's just because I can't draw proper double arrows in here, so I use that.
So it's, the thing is at equilibrium.
Yeah, these just like in your table, right? It's in your table, right?
The table, yeah.
Yeah. So this is one of the reactions like could be in your table, except this one's written as, no, this is a gain of electrons. This is a reduction. Okay. So major hydroxide, major atom, H2O for oxygen, H plus for H, and then electrons for charge. Grab someone, so in pairs, do this one on the board.
Oh, right. Yo. Eric. Wait, so. Okay.
Dylan, pair up. One walk. I think the person with cane is the one who doesn't have to walk.
Wait, so that's, anyway, they have to be equal, so could they be a positive and a positive?
Yeah, yeah. It could also be a negative and a negative.
Okay.
But grab Eshmore, do it on the board.
Look up. I haven't done it on the board. I need the marker.
I don't have a marker.
Pretty sure.
Do you want a marker? Or?
James, do you have a marker?
Eric, yeah.
Okay, 9 electrons. Just write this. Ready?
The water.
electrons plus 14 hydrogen plus Cr2O7 goes to 2 chromium plus 3
Plus 3.
plus 7 H2O.
Plus 2.
Oh yeah, plus 2. So we need 1 electron on that side.
Mr. Newfeld,
Yep.
would you come look at this please?
Do you have something different? How many electrons you got? Nope.
Mr. Neufeld?
Electrons are on.
Electrons.
But that's,
Oh.
Mr. Newfeld, if you have 14
Oh, I
electrons,
see.
or sorry, protons,
What's the charge on the right?
Noof, is this right?
water is neutral,
Oh,
so
it's
it's 7 plus 3, right?
Nope.
Oh, no.
How many of them do you
Plus
have?
6?
Plus 6.
Okay,
Oh,
very
so
small.
it's-
Oh, it's 2.
So it'll be,
Six.
There.
so yeah, 6.
Is that a 14 for H plus there?
Yeah.
Yeah.
Okay, then you're good.
Okay, Noob, are we good now?
You're good now. If you get down to 6 electrons, you're good.
Right, we have.
That was easier than I thought it was gonna be.
I don't know. I kind of understood that.
You just gotta like add stuff to either side.
I just don't understand what the goal is.
To balance it.
Yeah, but what is
That's
this?
to do with time.
Oh.
This is a half reaction. So this is, it's gaining electrons. It's a reduction.
What is it for? What am I doing with it?
If you also have an oxidation, you can now go through a process by which you put them together and get the overall complete reaction.
Why do I want that?
It's for the same reason you balance reactions all the time. If you're using the reaction, you need to know how much materials to get, how to have the right ratio so it reacts quickly, that sort of thing.
I guess so.
Okay.
We're doing something important to me in Pythagorean identities in math right now, and that's like significantly too theoretical. I have zero grasp of what's
Okay.
going on or why I'm taking it.
This was balance. If someone says balance an acid, you do the exact same thing. If a question says balance in neutral, like in water, exact same thing. You use H plus. Everything is the same. It's no different. But sometimes we have reactions that occur in basic solutions, and in basic solutions there is no H plus.
They just do OH minus and add protons,
So.
no?
Balance
Can you add protons?
in
Add
basic.
electrons to the other side.
I'm going to show you. So if I ask you to balance it in basic, we drown major hydroxide. So we take it balanced in acid. So it's the last step we do. Oh, and if you look at your book, just so that you're aware, hold it, is it
The
plus?
data booklet?
No, like in your Hebden,
Okay.
they will give you two methods of balancing equations. The method I showed you and one called balancing by oxidation number. They both give you exactly the same results. It doesn't matter which one you use. If you like the other one and you do it, that's fine. I have found the method that I've taught you is the one that's, I think, personally, having taught people, the easiest to understand initially. And when I've taught both, more often than not, people confuse them and don't do either one well. Some people like both. But if I just teach one, you always can balance, as long as you remember the steps, you're good. So if you do go and learn that, just don't mix them up. It's perfectly fine to do it either way. Now we have to drown this. There is no H plus. But what reaction do we know there is in water? If it's pure water, there's always one particular reaction. Hydrolysis. So we drown it. We take that H plus and we drown it with the same amount of water as it has. And we know that H2O does this. I'm just gonna pause there and wait for any questions to say, what did you do there?
Wait, how do you know if it's acid or neutral again?
Acidic or, if it just says balance it and it doesn't tell you, it's acidic or neutral.
Okay.
Because most things are in just water, it's neutral.
Why would you do something with base?
There's tons of reactions that can only occur in base,
Oh,
right? So there's like world chemistry, they'll have a reaction that works best in base, and so now you have to do a redox equation in base.
Yeah.
So
They're gonna tell you if it's like base or
Yes.
acid. Okay.
you've added algebraic equations before,
Yes.
so we just do that now. We've set it up so this cancels, and now we just add the rest in. But there's 14 on this side and 7 on that side, so what happens? H2Os. Pardon?
Add more water.
Well, we have 14 waters on this side, 7 waters on that side. Do they add? Do they cancel?
They subtract.
They subtract.
Subtract.
So we would get rid of that. And what does 14 become? 7. 14 minus 7 is 7. And then the OH minus, there's nothing on this side, so that just comes in. And our final result, the electrons would not change.
Why is it?
So we have to do the same thing
They-
as
They wouldn't change because you added 14 positives and 14 negatives, so the charge isn't going to change. Yeah, it's a good question because but you did something. But if you go through and count the charge now, you'll find it's still fine.
So basically we do the same thing as acid or neutral,
Yep,
and then on top of that we drown it in water.
Yep.
Or hydroxide.
yeah, you just do one extra step.
Okay.
Yeah,
So okay, because we have 2 H2s, we only need 7
Yeah.
waters. Okay. So 60 minus.
and now this side 14 minus 6 is, so this side's minus 8,
Wait, we moved.
and this side's minus 8, so it still works.
The next page, is that the same thing?
Just what I told you.
Wait, no, I'm getting confused. For the green part, it's like plus, or it goes to 14H plus 14OH minus.
Yeah, because when I drown 14H plus,
Oh, it,
I drown it with 14 waters.
yeah.
So I drown it in the same number. So those numbers have to match. That number has to match that number.
But there's.
And then when 14 waters
Then you cut
split,
it in half.
yeah, 14 to 1 and 14 to the other
What
one.
if I want to add oxygen to the left side? I'm doing the next question.
Well, at this point, you don't do this until the whole thing's done. So you will still do it.
I'm talking about like.
Well, I'm going to get everybody to do that one.
But then you cancel out the H pluses like the water.
Yeah, then you cancel out the H pluses.
What about the waters? You cancel the water.
And there's 7 waters on that side and 14 on this side.
Water.
So that means they would cancel.
Oh, there was originally 14, and then you cut it in half. So
Yeah.
you canceled. Oh,
Yeah, I keep knocking this over.
Look at me swinging opposite here. A little bit.
It's a little bit.
Just swing.
Any other questions? Okay, then let's say do that one on the board, and once you're right and you can show me, you can go.
But how do you add the O?
The initial part is exactly the same as before, major hydroxide. Major H2O, H plus.
Could I
negative.
add H2O on the left side, or would I not be able
It
to?
doesn't matter which side. To the side you need it on.
Oh, I thought it was limited to this.
No. We added to that side because the oxygen was on this side.
Is that the same with? Is that the same?
Same with H plus.
Okay.
Same with E minus.
You go back to this one.
Yeah, that one.
Yeah.
So,
Wait, can you go back to the basic example, please?
yep. So find a partner.
So first thing, balance it regular. And now we are missing O2.
Okay.
We're missing oxygen. So we have to add
2H2O plus PB.
But as soon as the house is back, Philip should work upstairs at the perfect kitchen table for a late night until he is done, or it is 11 p.m.
Plus.
I think we would only have to add it if we were already missing it.
plus
So you just have to add
3B.
Is that three?
Mr. Neufeld,
Yep.
Which
would
makes
this be correct?
Ooh, you were quick.
But then that also has to be 2, which means that this now has to be
Let me look at the numbers I'm looking for. I'm looking for. With,
Oh wait.
I want it done basic.
Okay, so we don't
Oh,
do that.
I want basic.
And then
So you have to drown major head dry side.
it's a drown,
So you have to do that last step we just went over.
which is adding water back
Mm.
to both sides.
Mm.
3H.
Sorry, my question is, why don't we just
Right.
not add all those, and just add another issue?
Yeah. So just not to use them.
Okay, so 4, your last number is 4 OH minus plus EB, which goes to HEB O2
So how
minus
do you do that?
plus
Add as many.
2H2O plus 3
Oh,
electrons.
we just do the H.
Oh yeah, sorry.
Ms. Neufeld,
Yep.
And then,
Okay, so we cancel.
Nope.
what do we
You're
want?
off by something.
plus an OH.
Your number of hydroxide is incorrect.
But wouldn't the 2 on this side minus?
And I think your number of electrons is incorrect too. So something has been thrown off. So you started off going wrong somewhere. Might be the number of hydrogens, might be the
That makes
number of
sense, okay, so
waters.
then there'll be 2.
Could you,
So erase what you've added and just start over and see what you've done to balance.
Mr. Neufeld,
Hold
Is
it.
this right?
Yeah, you might want to check your hydrogens.
wait, like at the
We
beginning?
need to do anything.
Yeah, it's the very beginning.
Oh.
Like it wasn't balancing acid correctly.
Confused with this? Add the H and OH.
Wait, but wouldn't I,
Dad?
We had three
He's
H's,
doing
there's three
it.
there.
wouldn't I need to balance the amount of hydrogen, so if I added 4 hydrogen here for the water?
Yeah. With one down, okay.
Because I need to add,
Final would be.
Yeah, two hydrogens there. That's good. Yes. How many hydrogens are on that
I
side?
think I got him 4.
And how many do you add on this
Because
side?
if this has a
Why?
negative here, don't we need another a negative?
Yeah, but we added a positive, so
I got him.
the side's neutral.
no,
So then this will be.
Nope, you're close. Why do you have 4 here?
P just neutral.
I mean, there is 4 there, but how many do you now have on this
hey,
side?
Echelon,
5.
You've got 5 and you do
5 there?
hold on.
two,
Oh, yeah, now we have
no. Hold it, so you got H2O.
Okay.
Did you drop a charge?
Two charges.
somewhere?
Because it doesn't give us a charge.
Right, no, so it's just regular PB.
How much?
So that's fine. So you would add,
Wait, what's the charge?
oh, that's what you've done. You put the 2 here, and it's actually there. So that, yeah, would take you right through the first.
There you go.
Yep, you're good.
Plus PB,
Who are you working with?
mine, or goes to
I'm a
H
lone ranger, and I am done.
minus
Where's the
plus
electron?
H2O plus 2 electrons.
Way back when, you missed the last step with electrons before you drowned it. So you need the electrons in.
So it's already neutral.
That side is neutral, not neutral. That side is plus 2. You've got 3 hydrogens, only 1 HCBO2.
Oh, is that 2 electrons?
And there you go.
Is this info, is that correct?
Good.
Yes. Mr. Neufeld, come look at this. No,
2.
your hydrogen
Why
is
does it
off.
go 4, 4, 5?
So yeah, so 3.
Just look at that.
No, because this is a separate equation, and it's just based on this. So you have 4,
But it's the
so you should have 4 and 4.
Okay,
And then,
No. You had 5 on this side. You're balancing that, so this is 4. This should be 4, but you made it 5 by making that a 4. What number should that? Yes, that was the problem. And that changes this as well.
Echelon, did you do any
So
other questions?
now I have 4 on both sides.
Yeah,
And then we cancel the.
yeah, and now you change those numbers to what you
I
need
did
to drown.
So I moved the sheet. I did 2 seconds. So like 6 questions.
Like the ones that you wrote, I did
have,
both.
yeah.
And like the electrons. And 2 of them.
Why do you have H2O?
The trig identities that he was talking about, he pulled out ones that we just started today.
I don't know what you're doing here.
And I was like,
Water on
Like
both
that.
sides. You can't- I don't even know how you get water on both sides. You had that, you added 2 waters, But why did you have 4 H2Os in there?
Because,
Oh, okay, so, oh, it's up
there's
here.
3 of these. Of
Okay, so you have 4 H's. How many H's are on this side?
Yeah, perfect.
Total. And, but yet you only need 4.
We're done.
So what number should that be? Right, and that will change your charge and change the rest of your balance.
We're done.
Yes. And
If you don't want to go get the nails taken off, what you do is you just slowly cut them as they grow out.
yeah, I even if I have gotten chemicals and taken them up, I find it really weakens the nail route. I don't understand how people get this all the time. Have strong nails. It's really hard.
Yeah, maybe don't do gel, just do regular nail polish.
But when I get gels,
No, but like,
I love the feeling. Like I feel like Wolverine.
Yes.
you should do it. Do it for the gays. If not, I'm not homophobic, so.
Honestly, the only thing it depends on is whether I get time between now and then.
Okay, this is correct.
I should also send out the
Make time. You have to make time for spa time, Mr. Neufeld. Self-care.
Yes.
spa time, spell care. I should send out the sign up one more time too.
Yeah, please do.
Yeah.
You gotta go for this. What's the pride fit? What are we thinking?
Oh, I'm gonna go like this or something.
Fit, what's the top?
I should go in a tie.
You should go in
I
sparkles.
should just go in my regular.
Sparkles.
It's so hot.
What's sparkles?
It's so hot. I have to, whatever I do, I have to be very, very cool because it is always so hot there.
Okay, then you need to find a T-shirt with sparkles.
Yes.
Okay, I'll try. I am getting stuff for the house today. If I can find a t-shirt